students, you are welcome again to this channel, A-Startutors Academy. We treat various topics that students are having challenges in them in chemistry and other sciences. We treat past questions to prepare students effectively towards their examinations. In the previous video, we treated the first 5 questions on calculations and some other related topics. In this video, we are going to continue from question number 6. We are going to look at another set of questions starting from question number 6 in continuation of the previous video. Kindly subscribe to this channel, drop your comment in the comment section, share and like as you watch the video. Let's go to the question. Which of the following oxide is an amphoteric oxide? Which of the following oxide is amphoteric? Firstly, what is an oxide? An oxide is a compound that is composed of only oxygen and other elements. An oxide is a compound that consists of 2 elements only, oxygen and any other element. It could be oxygen and another non-metal, or oxygen and a metal. So we have oxides, and there are different types of oxide. We have the 4 main types of oxide we have as follows. We have acidic oxides, we have acidic oxides, also known as acid anhydrides, acids and anhydrides, acid anhydrides. We also have basic oxide. We have basic oxides. We have amphoteric oxides. Amphoteric oxides. And we have neutral oxide. These are the 4 main types of oxides that we have. There are others, but these are the 4 main types of oxides we have. So students are expected to be able to identify the types of oxide with the examples. Acidic oxide are oxides of non-metals that can dissolve in water and form the corresponding acid. An acidic oxide is an oxide of a non-metal which dissolves in water and form the corresponding acid. We have examples like CO2, carbon 4 oxide, SO2, sulfur 4 oxide, SO3, sulfur 6 oxides, NO2, nitrogen 4 oxide. Those are the 4 very common examples, 4 main examples: CO2, SO2, NO2, and SO3. Those are the 4 main examples of acidic oxide. They dissolve in water and form acid. We have basic oxide, which are oxide of metals. Oxide of metals, they are compounds that react with acid to form salt and water only. That's neutralization. So that means basic oxides are bases because they can react with acid to give the corresponding salts and water only. Amphoteric oxides are oxides of metals too, but that can exhibit both properties of acidic and basic oxides. Amphoteric oxides, they are oxides of metals that share both the properties of acidic oxides and basic oxide. That is, in some reactions they can behave as acid. In some other reaction, they can behave as bases. Examples of basic oxide: sodium oxide, potassium oxide, calcium oxide, magnesium oxide, and so on. Examples of amphoteric oxide: zinc oxide, aluminum oxide, lead-2 oxide, and so on. Neutral oxide, they are oxides of non-metals which are neither acidic nor alkaline, neither acidic nor basic. They are neutral. We have common examples like carbon monoxide or carbon 2 oxides, going by IQ Park naming. Water H2O, dinitrogen 1 oxide, that is N2O, and so on. Now back to this question number 6. The one that is amphoteric oxide is aluminum oxide. That's C. Aluminum oxide is an amphoteric oxide. It shares the properties of acidic and basic oxide in reactions. Question number 7 is about the calculation of oxidation number of chlorine in KClO3. Let me quickly intimate you with the IUPAC name of this compound. This is a compound we call potassium. This is potassium triosochlorate 5. Triosochlorate 5. This is the IUPAC name of this compound. It is very essential for students to know how to name chemical substances. It is very important to know how to name chemical substances. Most importantly, the IUPAC or the modern names of the substances. So this is called potassium triosochlorate 5, commonly known as potassium chlorate. Now, in oxidation number, students are expected to be familiar with the rules. There are rules guiding us when it comes to calculating oxidation number or oxidation state of elements. I'm not going to mention all the rules now. In upcoming videos, we are going to look at how to calculate oxidation numbers going by the rules. So we are going to explain better in that video. Just watch out for the video and try to subscribe so that you can always get updates on any topic or any past questions treated. Now, the first thing we are going to do, we are going to assign the oxidation numbers of this element today. Potassium, the oxidation number of potassium in this compound is +1, +1. In any compound that contains potassium, another group 1 metals, they all have +1 as the oxidation number in compounds. For oxygen, the oxidation number of oxygen is going to be -2 in this compound, but it can as well be -1, but for peroxide. So since this is not a peroxide, so if you have oxygen, if you have a compound that contains oxygen, first of all, identify the compound as either a peroxide or not. If it is a peroxide, you assign -1 as oxidation number of oxygen atom. But if it is not a peroxide like this, the oxidation number of oxygen will be -2. Now for chlorine, that's the one we are looking for. You can represent by N letter. Then the next thing is to form equation of all these oxidation number. And when you are doing that, consider how many atoms of each element you have. You must put them into consideration. Potassium, we have 1 atom, so I'm going to have 1 atom multiplied by the oxidation number of potassium plus 1 atom of chlorine multiplied by the oxidation number, which is represented by X because that is what we are looking for, plus 3 atoms of oxygen multiplied by -2, and the sum of these oxidation numbers will be equal to 0 according to the rule. There is a rule of oxidation number that states that the algebraic sum of the oxidation numbers of all the atoms in a neutral compound or in a compound which is not an ion is 0, and that is to say that the overall oxidation number here is 0. That is overall charge here is 0. We don't need to put the 0, but when you don't see anything there, it means 0 because it is neutral. For neutral substances, molecules or compounds, the oxidation number is 0, even for an element. So for oxidation number of a free element or of a molecule or a compound, overall oxidation number, overall oxidation charge is 0. So we equate this sum of the oxidation numbers of all these atoms to 0. Then we can now solve it to get the value of X. This is going to be +1 plus X minus 6 equals 0. So plus X minus 5 equals 0. X equals 0 plus 5. X equal to plus 5. So the oxidation number of chlorine in that compound is +5. When you are talking about oxidation number, you must put the charge. Don't just write 5. You have to put the charge, the sign, either plus or minus, positive or negative. Oxidation number is mostly positive or negative for elements in compound state. So that is why this is called potassium triacylchlorate 5. So this is how to solve for the oxidation number of chlorine in that compound. Question number 8. Which of the following salts undergoes hydrolysis? Which of the following salt undergoes hydrolysis in water? Firstly, let me explain what hydrolysis means. Hydrolysis is just a reverse process of neutralization. There are inorganic salts that can be hydrolyzed in water, and we also have organic salts that can also be hydrolyzed in water. So generally, hydrolysis is a chemical reaction between a salt and water to form the corresponding acid or alkaline. If a salt dissolves in water and the resulting solution is either acidic or neat or alkaline to litmus papers, then it means the salt is hydrolyzed in water. There are some salts which do not undergo hydrolysis in water at all. What are those salts? Those are the salts of strong acids and strong bases. Salts that are formed from reaction of strong acids with strong alkalines or bases. And they are just 6. So the salts that do not undergo hydrolysis in water are sodium chloride, potassium chloride. These are salts of hydrochloric acid. We also have sodium tetraoxosulfate 6, or simply put sodium sulfate, potassium tetraoxosulfate 6 or potassium sulfate. These are the salts of tetraoxosulfate 6 H2SO4 acid. Then we have sodium triazonitrate 5, that's sodium nitrate, potassium triazonitrate 5, potassium nitrate. These are the salts. These salts are produced from reaction between the corresponding strong acid and strong bases. When they dissolve in water, the solution remains neutral. So when the resulting solution of these salts is neutral, it means the salt did not undergo hydrolysis in the water. But salts of strong as a weak acid and weak bases, they undergo hydrolysis in water. Now from this option, the salt which will undergo hydrolysis in water is ammonium chloride. Ammonium chloride will undergo hydrolysis in water. But the other options, sodium chloride, potassium triazonitrate 5, sodium tetraoxosulfate 6, those are salts of strong acid and strong bases. They are not hydrolyzed in water. Now let's see how ammonium chloride reacts with water during hydrolysis. The ammonium chloride solid dissolves in water and we react to form ammonium hydroxide, which is the base, and also we form hydrochloric acid. These are the original acid and base that react to form the salt. So this is the equation of hydrolysis of ammonium chloride. Now the resulting solutions, because these two products, the acid and the base, that combine originally to form the ammonium chloride, in the solution, this consists of these are present in the solutions. So the solution is going to be alkaline. Why? Because the HCl is stronger. The one that is stronger than the other will influence the pH of that solution. So this is a strong acid, while this is a weak base. So that means the overall solution, the entire solution of ammonium chloride will be acidic. It will be acidic. The solution will be acidic, slightly acidic. So that means if you dip a blue litmus paper inside this solution, it will turn slightly red, indicating that it's an acidic solution. And that occurs because of hydrolysis. So hydrolysis is when a salt dissolves in water and we have to form either acid or a base solution. That is, the solution will not be neutral. So the correct answer here is C. Let's go to the next question, question 9. Calculate the number of moles in 11 grams of carbon dioxide, that is CO2. When we are calculating mole, there is a formula that students should have been familiar with, which is represented by this, where the N is the mole that we are looking for, the value in mole. The small m represents the mass given, that is 11 grams in this case. The capital M is the molar mass, which we are going to calculate, the molar mass of that CO2. Molar mass of CO2. We are going to calculate that. So the molar mass, because we know the substance, if you know the substance, then you can calculate the molar mass by adding up the atomic masses of the element present. So carbon is 12. So that will be 1 times 12 plus 2 times 16. 1 atom of oxygen is 16. Add everything up, you have 12 plus 32, making 44 grams per mole. Now we can now substitute these values back to the formula. So the mole is going to be 11 over 44. Everything will be in mole. So this will give us 0.25 mole. So this is how to determine the mole, the number of moles of 11 grams of carbon dioxide. Question 10. So the answer is A. The last question in this video, we are to state the IUPAC name of this compound. This inorganic compound precisely is a carboxylic compound. Whenever you see this group of atoms, this is what we call the carboxy group or carboxylic group. The carboxy group is a functional group in carboxylic acid. It's a functional group in carboxylic acid. So carboxylic acid are easily identified by this group in their structural formula or in their molecular formula. So we are to name this. Now when you are naming an organic compound, there are rules to follow. Number 1, we are going to number and identify the number of carbon atoms. This is a straight chain of carbon atoms rather. So we are going to number for functional groups that contain carbon atom. When a functional group contains carbon atom, you start your numbering from that carbon atom. So I will start from here 1, 2, 3. So we have 3. There are 3 carbon atoms. So that means the name of this compound is going to be propanoic. Prop means 3 carbon atoms. Propanoic acid. That is the name. Propanoic acid. So the answer is B. Don't forget to share, to like, and to drop your comments in the comment section. So we have been able to solve these 5 questions in this video. We have been able to solve these 5 questions. Question number 6 to question number 10. Don't forget, you can drop your comment in the comment section. If there is any topic that you want us to treat together here that you want me to explain for your own understanding, kindly contact me through this WhatsApp shown above here. You can contact me through this WhatsApp number. You can message me on WhatsApp. You can give a call, and we'll be able to attend to your immediate challenges. Thank you.